Hello, this is Group 19 Senior Design 1 project presentation on our automatic 3D printed part dispenser. So, why did we choose this project? Well, when a 3D printed part is picked up in the HVAMC, there is contact between the employees and the student. This contact deems as not only a safety risk, especially nowadays, but also as interruption to the HVAMC employees. Also, students can't pick up their parts once the HVAMC is closed. An automatic 3D printed part dispenser located in the lobby of the EIH can solve some of these key issues. This dispenser will allow for individual housing of students' unique 3D printed parts. It will work so the HVAMC staff can preload the student's part into the dispenser, and students will enter their unique order number into the machine to retrieve the part. This process will allow for students to keep their distance from the HVAMC and will also allow for a cleaner workflow for their employees.
This semester's goal was to design and construct a working prototype. We developed the prototype to test our initial dispenser design and to prove concepts that would be present for next semester's design. The prototype is constructed of a metal frame, a 3D printed carousel housing unit, and a 3D printed gear train to allow more torque onto the carousel shaft rotation. A PIC microcontroller is used to read input from a matrix keypad, display characters on an LCD screen, and rotate a stepper motor that connects to the gear train. This demonstration shows how a part can be retrieved from the prototype. Here I'm entering an order number into the keypad, and LCD displays the numbers as I type them. The program recognizes that I entered a correct order number, and you can see how the carousel rotated to the cell that contains my order. Once I retrieve my order, the LCD screen prompts me to press the pound key, which rotates the carousel back to the starting position. The program now recognizes that this is an empty cell and clears this order number for the memory, so it cannot be entered again.
Chris demonstrates entering in the admin password to enter admin mode. The admin screen appears with options to calibrate the carousel's position and set new order numbers. He selects setting new order numbers as the program recognizes the empty cells of parts retrieved. This automation allows the staff at the HVAMC to place in parts and set new order numbers with ease and certainty. The cells, parts, and numbers correspond properly. He places the part in the space and enters a new 6-digit number to be saved. Calibration mode allows for fine-tuning of the initial position of the carousel in this mode as well. Another option that the staff can choose is viewing currently saved numbers shown in this picture. This demonstration shows what happens when a wrong order number is entered in the dispenser. The program will tell the user that the order number was incorrect and will allow them to re-enter the number. If a wrong password is entered 3 times in a row, the program will lock the screen and an HVAMC staff member will need to enter a special code to unlock it.
Throughout the semester, we were able to solve a few of the open-ended questions we had during the design phase. We proved that pre-drilled steel framing could be used to create a strong frame for our prototype, a feature that could be simply scaled for our larger future machine. The electrical team was able to produce a functional program to store, remember, and deliver parts. It can withstand power outages and mechanical resets without losing data. The bearing shaft fit proved to be crucial. In the close-up of the gear train function, you can see the run-out induced in the shaft due to a poor fit. We will address the fit in a future machine to ensure the gear train has reliable support. We also were able to see what kinds of gears printed well within the precision of the 3D printers. The frame ended up being strong, but there were a few issues with straightness and warping that will be accounted for in the next version.
We learned how to multiplex keypad and motor coil pins, as most of the remaining microcontroller GPIO pins were not working properly. As well, we used I2C and an EEPROM to save existing order numbers of students' parts and the ability to replace and save new order numbers.
The carousel design made sense after we printed it on the large format printer. We will have to figure out how to expand this, as our final carousels will be around 3 foot in diameter, a size that's obviously too large for one piece. We were thinking about making it as an assembly of printed parts, or whether a metal design would be easier and more practical to make. We will design a more effective method
of turning on and off the motor if the motor's coil signals remain multiplexed to the keypad. A relay would be a good feature, and a better design of this will allow the motor to turn on and off when required. The locking door mechanism we plan to implement and secure with an electronic solenoid next semester. Aaron Nelson provided valuable feedback. Instead of manual calibration of the carousel, the implementation of a Hall effect sensor to improve robustness and automation of calibrating the carousel each time it returns to its home position.